connective tissues are an incredibly diverse set of tissues. So let's look at the functions or some characteristics, some significant characteristics of connective tissues. First of all, wholly diverse. And when we get down to classifying connective tissue, you will see the mad number of tissues that are included in connective tissue land. It's why there are half of all of our tissues that we're going to learn today are connective tissues. Most connective tissues are vascular. Now think about that for a second. So what? Well, why is this relevant? Who is avascular? Epithelial tissues are avascular. All connective tissues except for cartilage. Bone and cartilage are both connective tissues. Cartilage is an avascular connective tissue, and we'll talk about the significance of that when we talk about bones and joints. Otherwise, connective tissue really is how epithelial tissue gets taken care of. So yes, please be vascular. Connective tissues are where the cells in epithelial tissues were closely packed together. In connective tissues, the cells are usually far apart. And there's lots of stuff in between the different cells. In a connective tissue, there are no spaces. Now, I say that, and I guarantee in lab today, you will look into your microscope and you'll be like, dude, this is an example of dense irregular connective tissue, and look, there's a space and there's a space. There's definitely things that look like spaces, and often in histology, the slides have what we call artifacts, which means there are spaces in places where that's not actually where a space is in life. It's a space because the tissue dried up and shrunk, or the process of slicing it made a hole. And so sometimes you'll see spaces. So histology is kind of magic sometimes, where you get to know, like, is that a real space or is that not a space? And you will get a sense of it as we work through the course. In general, you can make the assumption that if you are in a connective tissue, you're not going to be seeing a defined space. What are connective tissues? Well, funny that you should ask such a thing. They do have a definition. Connective tissues are cells embedded in a matrix. Okay, look at how I'm going to do this. Cells in a matrix of ground substance and fibers. But of course, that is what a connective tissue is. We learned that cartilage is a connective tissue. If cartilage is, so is bone. So is blood. So is fat, adipose. These are examples of connective tissues that are, like, weird. Like, oh, man, that's a really diverse group of things. Plus, you have, like, normal connective tissues, like dense regular or dense irregular connective tissue. Sometimes identifying the matrix of ground substance and fibers is easy, and you can see the cells, like, embedded in there. Other times, not so much. The ground substance is like the, I don't know. The ground substance is like the soup. It's like really, I'm going to throw this out there for you. It's the extracellular fluid of the tissue. So really, this ground substance is whatever the fluid is that the fibers are sitting in. Ground substance includes the fluid plus any solutes in the fluid. Some solutes that are found, peptidoglycans. Have you ever heard of glucosamine? It's a supplement that you can take for joint pain. It's actually a super hydrophilic solute found in the ground substance of connective tissues like cartilage. So the more of these hydrophilic ground substance things like glycosamine, whatever I just said, the more fluid that can be moved in and out of the cartilage. Moist cartilage is healthy cartilage because you remember it doesn't have any blood supply. So if you have a lot of water in the cartilage, you actually are going to diffuse your nutrients and garbage faster and more efficiently. So the solutes can play a really important role in sort of maintaining the characteristics of that extracellular fluid. In that fluid, now, different connective tissues are going to have different things in their extracellular fluid. Think about blood. The blood plasma is the ground substance. And blood plasma doesn't, I mean, it's mostly water. There's proteins in there, and there's salts and all sorts of good stuff, but it's a very fluid ground substance. Fibers are found running through that ground substance, and we actually have 3 different flavors of fibers that we're looking at. The biggest, actually, truly the biggest fiber that you're going to look at is collagen. They're kind of thick. They're strong. The nature of the fibers is going to tell you the characteristics of the tissue. The nature of the matrix is going to tell you the characteristics of the tissue. So think about that for a second. Think about bone versus blood. Both of them are connective tissues. Both of them have a matrix of ground substance and fibers. Bone matrix is solid. There's the solutes in the ground substance are calcified, and the fibers are strong collagen fibers. Blood fibers are rare. There's not very many fibers, and the ground substance is lots. So the characteristics of our matrix will determine what we're going to see for our connective tissues. Collagen is one fiber type. We also have elastic fibers. There's elastic cartilage that is found like in your ear and the tip of your nose. The cartilage found in those places is elastic. That just means that there are these elastic fibers running through the extracellular matrix. And then there's also these fibers called reticular fibers. Reticular fibers, again, are just another kind of fiber. The fibers that we're going to see today in our studies, we're going to see collagen fibers and elastic fibers. And being able to identify the fibers will help you distinguish between different kinds of connective tissues and other things that might look like connective tissues but actually aren't. So that's what a connective tissue is. Yeah? Excellent. The cells. I didn't tell you anything about the cells. This will shock you. The kinds of cells that are found in connective tissue vary depending on the connective tissue that you have. Blood cells are found in blood. Adipose tissue, connective tissue, is composed of adipocytes or adipose cells. Bone has osteocytes. Most of the tissues have cells called fibroblasts. Fibroblasts. Blast, I don't know. We should look up what it actually means. But in my brain, blast means building. And so fibroblasts are blasting out fibers. It's like they're pooping out massive amounts of fibers. So they're actually the fiber builders in connective tissues. They're building collagen, elastic, and reticular fibers and barfing them into the matrix, which is how you end up with them. In addition to fibroblasts, you have a doo-doo load of immune cells in connective tissues. And they're doing their job of actually going around and patrolling the area. White blood cells are immune cells, and they actually can travel from the bloodstream and into the connective tissues, and they go out there to make sure that you didn't get infected with anything crazy, because you know that happens sometimes too. Let's look at how we classify connective tissue, which is not a simple process considering how complicated the tissue or how diverse the tissues actually are.